Concrete process. Background. Concrete is a hardened building material created by combining a chemically inert mineral aggregate, usually sand, gravel, or crushed stone, a binder, natural or synthetic cement, chemical additives, and water. Although people commonly use the word cement as a synonym for concrete, the terms in fact denote different substances. Cement represents only one of several components in modern concrete. As concrete dries, it acquires a stone-like consistency that renders it ideal for constructing road, bridges, water supply and sewage systems, factories, airports, railways, and other structures. The words cement and concrete are both of Latin origin, reflecting the likelihood that the ancient Romans were the first to use the substance. One example of Roman concrete construction remains in the country that encircled the Mediterranean, where Roman builders had access to numerous natural cement deposits. Natural cement consists mainly of lime, derived from limestone and often combined with volcanic ash. It formed the basis of most civil engineering until the 18th century, when the first synthetic cements were developed. The earliest man-made cement, called italic lime, was developed in 1756 when an English engineer named John Smeaton needed strong materials to rebuild the Eddystone lighthouses off the coast of Devon. Although the Romans had used hydraulic cement, the formula was lost from the collapse of their empire in the 5th century AD until Smeaton reinvented it. During the early 19th century, several Englishmen contributed to the refinement of synthetic cement, most notably Joseph Aspdin and Isaac Charles Johnson. In 1824, Aspdin took out a patent on a synthetic blend of limestone and clay, which he called Portland cement because it resembled limestone quarried on the English Isles for Portland. However, Aspdin's product was not as strong as that produced in 1850 by Johnson, whose formula served as the basis of the Portland cement that is still widely used today. Concrete made with Portland cement is considered superior to that made with natural cement because it is stronger, more durable, and of more consistent quality. According to the American Society of Testing of Materials, Portland cement is made by mixing calcareous material such as limestone with silica, alumina, and iron oxide containing materials. These substances are then burned until they fuse together, and the resulting mixture or clinker is ground to form Portland cement. After the refinement of Portland cement, the next major innovation in concrete technology occurred during the late 19th century when reinforced concrete was invented. While concrete easily resists compression, it does not tolerate tension well, and this weakness meant that it could not be used to build a structure like bridges or buildings with arches that will be subject to bending action. French and English engineers first rectified this deficiency during the 1850s by embedding steel bars in those portions of a concrete structure subject to tensile stress. Today, different types of concrete are categorized according to their method of installation.
The manufacturing process. The manufacture of concrete is fairly simple. First, the cement, usually Portland cement, is prepared. Next, the other ingredients, aggregates such as sand or gravel, admixtures, chemical additives, any necessary fibers and water are mixed together with the cement to form concrete. The concrete is then shipped to the work site and placed, compacted and cured. Preparing Portland cement. The limestone, silica and alumina that make up Portland cement are dried ground into a very fine powder, mixed together in predetermined proportions, preheated and calcined, heated to a high temperature that will burn up impurities without fusing the ingredients. Next, the material is burned in a large rotary kiln at 2,550 degrees Fahrenheit. At this temperature, the material partially fuses into a substance known as clinker. A modern kiln can produce as much as 6,200 tons of clinker a day. The clinker is then cooled and ground to a fine powder in a tube or bowl mill. A bowl mill is a rotating drum filled with steel balls of different sizes, depending on the desired fineness of the cement, that crush and grind the clinker. Gypsum is added during the grinding process. The final composition consists of several compounds: tricalcium silicate, tricalcium aluminate, and tetracalcium aluminoferrite. Missing. The cement is then mixed with the other ingredients, aggregates, sands, gravel or crushed stone, admixtures, fibers, and water. Aggregates are pre-blended or added at the ready-mix concrete plant under normal operating conditions. The mixing operation uses rotation or stirring to coat the surface of the aggregate with cement paste and to blend the other ingredients uniformly. A variety of batch or continuous mixes are used. Transport to work site. Once the concrete mixture is ready, it is transported to the work site. There are many methods of transporting concrete, including wheelbarrows, buckets, belt conveyors, special trucks, and pumping. Pumping transport large quantities of concrete over large distance through pipelines using a system consisting of a hopper, a pump, and the pipes. Pumps come in several types: the horizontal piston pump with semi-rotary valves and small portable pumps called squeeze pumps. A vacuum provides a continuous flow of concrete with two rotating rollers squeezing a flexible pipe to move the concrete into the delivery pipe. Pressing and compacting. Once at the site, the concrete must be placed and compacted. These two operations are performed almost simultaneously. Placing must be done so that segregation of the various ingredients is avoided and full compaction with our air bubbles eliminated can be achieved. Whether chutes or bogies are used, position is important in achieving these goals. These rates of placing and of compactation should be equal. The latter is usually accomplished using internal or external vibrators. An internal vibrators uses a poker housing a motor-driven shaft. When the poker is inserted into the concrete, controlled vibration occurs to compact the concrete. External vibrators are used for precast or thin in situ sections, having a shape or thickness unsuitable for internal vibrators. These types of vibrators are rigidly clamped to the formwork, which rests or an elastic support. Both the foam and the concrete are vibrated. Curing. When is placed and compacted, the concrete must cure it before it is finished to make sure that it doesn't dry too quickly. concrete stage is influenced by its moisture level during the hardening process. As the cement solidifies, the concrete shrinks. If site constraints prevent the concrete from contracting, tensile stress will develop, weakening the concrete. To minimize this problem, concrete must be kept damp during the several days it requires to sand and harden.